I'm John Rogers. I've worked for Bradbury for about 10 years now. I started out my career there as a test technician. I was setting up equipment, working on stuff out on the shop floor, doing the debug, make everything work as it needs to be, go out to the customer's facility, install the new equipment, roaming around doing some customer service jobs. Somebody calls up, they need help. I was kind of that guy. I was the wrench turner for about 6 years, and then I transferred into our customer service department. And now I'm on the other end of the phone when you call up because your machine has that trouble, and then I get in a plane and go fix it. So I'm still the hands-on guy. I also do a lot of technical support. I'm not the biggest on electrical. I understand it fairly well. I can get you through the prints. I can talk you through it and look and see what's going on if you're having trouble. As far as controls, I understand the controller very well. As far as the nuts and bolts, that's my stuff. I'm the wrench guy. So that's kind of my background. That's what I do most of the time. Is when you're having some sort of issue at this point, I'm more inapt to come and figure out what changed. Why did it work yesterday and it doesn't work today? I'm that guy. And a lot of what I'm going to talk about today is going to stem back to that. It's going to be that what could you have done preventative wise to avoid the situation we're in today? Why are we broke down? Why is this not running? What's changed? Why is your profile changed? Why are you continually having this or that trouble? A lot of the things I'm going to touch on are, yes, they're just maintenance, but it's more in the preventative side. It's more in the, why is my panel changing? Why am I seeing, drive faults that I didn't used to see? Am I seeing more resistance? Why am I, those kinds of things. That's kind of what I'm all about. Feel free to throw up a hand, yell at me when we're talking. If there's something you want to cover and it's in the area that I'm talking about, I'm cool with that. That's great. Also, if you want to hit me up afterwards, that's all fantastic. So I'm going to cover kind of generally, and this sounds simple and it sounds like duh, but there is some valuable information in your manual. I don't know if you bought Bradbury, I don't know if you bought from one of our competitors or from anybody, but there is valuable information in there for the right reasons. They put your roll tooling prints in there most likely, your lubrication schedule, and your spare parts list. There are so many times that we get into a situation where those are the things that you really need to get your machine going, and it's available to you. Maybe not the most user friendly. Sometimes people they know that's the paper that came with the machine they love. Anywho, we're gonna go through roll tooling a little bit, talking about how I gap things, what to look for making sure your alignment's correct, looking for the wear that has been there, or trying to diagnose the fact that you have worn tooling and that's the reason you have oil canning, those kinds of things. How I inspect arbor bearings. Talk about lead-ins quite a bit. I'm big on alignment. When I get to somebody's facility, I'm going to go over their alignment, whether they think it's right or not. It's so huge. It's paramount. Alignment is king. It really is. In so many things in the roll forming world, checking out your lead-in wear. Obviously, like we talked about your lubrication schedule, about either make a schedule. If you have a schedule, you stick to it. Whatever it takes. Be preventative. Do the right thing for your machine. And then I get into a little bit of troubleshooting. That's kind of my passion. So taking care of that equipment, trying to get you a good product is kind of where I live. So first of all, the valuable information that you already have on your equipment. I don't know who you bought from, or if you have anything yet, or if you're in the market, whatever it is. Most likely, especially if you got it from Bradbury, you're going to have your cross-section drawings, your overform passes pushed out, your dimensions on there. Your roll tooling prints are going to help me or one of your people diagnose what you got going on when you're having trouble with your panel. Obviously everybody's seen an ag panel. If your panel's wide and you come in here and realize that 49 degrees doesn't make 49 degrees, well, then I want you to come down on pass 11 and 12. That's kind of simple. Sounds silly, but it's there. I mean, these are the things that you can look through for the information that you have available and use it to your advantage. If that cell isn't measuring 9 inches across from top to top, why? I can't get my panel. Well, go through and measure. Find out, is that 99 or is that 49 degrees? Do you actually have the depth on your miners? Are you getting the peaks as expected? if you get your panel in dimensionally first, it's probably going to be flat. You know, I mean, that's kind of the way it is. Also on your manual, like we said, your lubrication schedule. The amount of times I go into somebody's facility and we're having trouble with whatever it is, and I ask Bob the operator, hey, grab me your grease gun. If it takes Bob more than 10 minutes to find me a grease gun, he doesn't use it every day. He doesn't use it once a week. And on a Bradbury Rollformer, there are 136 grease zerks on Arbor stands on a 16-pass. That's just the way it is. If you can't find the grease gun and you're supposed to be hitting 136 of those once a week, you aren't doing it. You know, take care of that machine. It's going to take care of you. You know, here's an example of how ours are. In my opinion, this is set up very well. Whether your equipment is set up the same, if you have Bradbury or not, we don't have the best detail right here, but on our prints, the way this calls out, so like bubble number 3, that's going to say Arbor bearings. It doesn't on here because it came off the potato, but this is 136 of them. The frequency is B. B means weekly. If you look at type 1, it's going to say LXR EP2, which is your grease, right? Whether you guys use something very similar to that or not, getting something on paper, getting something on the schedule to where no matter what, this is what we do, whether we're in a hurry, whether we got downtime, whether we don't. You're going to look at your gearboxes once a month, check the level on them. You're going to check your roll tooling for wear. You're going to go through and look at your all of your lubrication points. You know, you're going to look at those chains. You know, just get on schedule and make it part of your day to day. You know, it's as important to make sure that machine is acting correctly as it is to get the material out the other end. I know your production manager is going to tell me to shut up. he doesn't want to hear that, but it's honesty. You know. Also, spare parts list. I'm standing up here representing Bradbury, and I'm going to sell you spare parts. That's part of my job. But also, spare parts on your shelf limit your downtime. It is a fact. It's the way it is. You know, if you call up and we go through a few things and we figure out that the reason why your machine isn't working is because you have your low air pressure switch on the back of your brake isn't working. It's faulty. It's went out. It's finally lost its mind. And it's on this list that says spare parts list, and it has a check mark next to it that's critical, and it has a lead time on it that says 2 weeks, and it costs $70 for that switch. Do you want to be down for 2 weeks because of $70 part? No, nobody wants that. Have the spare parts, some of the criticals. You know, go through your machine, figure out what it is that's going to hurt you the most, and have that piece on the shelf. You know, those are the kind of things that limiting downtime is part of maintenance. You know, it's a preventative, it's a preparation thing. You know, be prepared. I'm big on having some of your critical spares on the shelf and be ready to throw them on at a moment's notice. And then you call up and we scramble around to try to find that part quicker than 2 weeks. If you don't have it on the shelf and we're scrambling around trying to find it quicker than 2 weeks, you're not making material. You're not running anything. That's hard on everything. So getting into lubrication, this picture is of a brand new machine on our floor, and you can see that nothing's lubed yet. Your spur gears are dry, the chains are dry, all that kind of stuff. There is oil in the gearbox, but it was just a good picture of a double high Rollformer with all kinds of things in it at the same time. I thought it was helpful. You can lube those chains, lube the spur gears, take a look at your gearboxes as per your new lubrication schedule, and prolong the life of your roll tooling, your bearings, or the quality of your panel just from back here. If you let those chains get super loose and worn because they haven't broke, that doesn't mean anything. It doesn't help you because you're gonna wear your spur gears out faster because your chains have chatter in them. If you have chatter in the chain, you get chatter in the spur gear, that transfers to chatter in the roll tooling. You're gonna start seeing those little shiny marks on your roll tooling. You're gonna start seeing a radius on your panel that has that staggered look to it. You can see it. It's not super defined, but it wears out your roll tooling faster. It messes up your radiuses. So make sure, per the schedule, you go and look at that your bearings, your bushings, your gearboxes, chain sprockets, and spur gears are taken care of correctly, on schedule, every time. That prolongs the life of your equipment. So here's an example of that. So how well you can see it. You see this shiny chatter in this roll tooling? That absolutely came from a worn out chain that ended up wearing out a spur gear, and then we get the chattery mark down through the panel. You know, this roll tooling, most likely the Arbor, probably the keyways, were shot because somebody didn't lube a chain, you know, and you're like, that's true. You know, I see it fairly often, actually. Preventative maintenance avoids problems way down the line. That piece of roll tooling was far more expensive than a can of lubrication on your chain. Far, far and away. You know, so take the 5 minutes, spend the time, keep your lubrication schedule up. It's a big deal. Checking on your adjustment dials. I'm not sure, everybody's are a little bit different. The general idea is all about the same. This adjustment assembly is compacted inside of the top of the stand. We have an acorn nut that goes up there on the threads to jam it, to pull all the slop out of that out of the adjustment assembly. This is something that kind of gets overlooked a little bit, and we see that if those adjustment assemblies get worn out, the teeth inside them, or the threads inside of that assembly get worn. We have extra slop in the bearing, more bounce, more bounce, more bounce. As that panel comes through, it's going to dump, top and bottom, top and bottom, top and bottom, starts wearing more and more and more and more. That transfers to bearings, it transfers to arbors, it transfers to roll tooling. When you get a hold with your wrench and you go to switch from whatever settings you have for your 26 gauge, 29 gauge, and you go to adjust it and it spins easy enough you don't need the wrench, take a look at it, tighten that thing up, see if you got a bunch of slop in it. The easiest way that I do is inside the window of the stand. I tighten the acorn nut down, I get a block in there, grab a pry bar, and see how much slop is in that stand. You'll be able to see that ball thread going up and down. That's a quick check to see why I'm getting a lope in my panel, you know. Checking gap. So I'm using an ag as an example. I think everybody in here is probably more familiar with that. Like on an ag panel, you're going through the gap tooling. I want to see that gap in this area, on the later passes, outer towards, on the wider edges, both sides, with the feeler gauge in the horizontal, and make sure that that gap per your feeler gauge matches your dials. If those dials have been spun around the wrong direction, so if you're at 50 thousandths on this dial and you tell Bob the operator, hey, we're changing over and your new one is at 20 thousandths, and he doesn't go 50, 40, 30, 20, he goes 50, 60, 10, 20. Now this half of the stand is off and your arbor's cocked, right? That's, you know, it's paramount to get that vertical adjustment correct before you even begin to look at any of your alignment top to bottom arbor, because that angle deflection changes it enough that it won't even line up right. You know, if you change it 60 thousandths from where it's supposed to be, it's leaning, and you're gonna start getting some weird things in your panel. Why don't I lap anymore? Why am I open on this side? And if somebody's not actively making sure that your machine's set up right, and he says, man, this must be hard material, I'm gonna come down harder on past 15 to try to get my lap right, but you're already cocked and you come down and this side's deeper than it was originally, you're gonna run your tooling together. Now you're buying roll tooling. You run that tooling together, it doesn't take very long. I don't know if you all seen that, you'll wear it out quick. Once horizontally we're correct, I like to go in and pin gauge, and I'll pin gauge in here. And I'll check it on both sides. And that's a really good way to know if my top and bottom tooling are in alignment. Looking for a pinch point on roll tooling is one of the most important things. You're gonna see that shiny spot inside your radius, and you're gonna see the bubbly looking radiuses on your overform areas that makes your panel look terrible, you know, and that's generally just from a pinch point. You're coming down too super tight, you're elongating the radius, you know, you're hurting things, you know. So to check a quick clearance thing is I grab a piece of white paper and a mirror, and I can just look real quick, grab that mirror and look through there. Look at the next pass, look at the next pass, look at the next pass, get in and out fairly quickly and make sure that you have good clearance everywhere. You know, that's something you want to do when all of a sudden my panel doesn't look right. Did something get adjusted incorrectly? Am I pinching it somewhere? Am I running tooling together? Am I about to cost myself a lot of money? You don't want to go down that road. Talking about alignment, one of the things that we do, and I'd say it's fairly common in the industry, if you have a Bradbury machine on a panel line, you're going to be able to do this. You'll be able to take a panel or a straight edge and go from the face of the tooling in many areas on your Rollformer and make sure that's still in alignment. If pass 4 is sticking out that way and your straight edge is touching on 5 and 3, you have spacers out of place, you don't have your arbor nuts tight, you got a bearing that went out, you know, somebody put it back together wrong, they got a split spacer they forgot to put in, something like that. This is a quick check as well when you're having some trouble. You know, you can slap that thing up there. If the faces of your tooling don't work on your machine, whoever your manufacturer was, most likely your radiuses are. You can check your radiuses, you can go through a string line. Checking for pass to pass to pass alignment is paramount. If you want a straight rib on your panel, you want the roll tooling to be in a straight line down the middle, you know what I mean? It's only following where it goes. It's gonna follow the way it was put together. You know, that panel's gotta follow where it goes. We were talking about worn tooling. I went on site to help these people out. This is standing seam, and if you can see that mirror finish, and obviously this has had some birthdays, like a lot of birthdays. That mirror finish is where there used to be roll tooling and it is worn away, it's gone. And I looked at the footage on their controller and it was a huge number. It was an astronomical number, and they told me, oh, we replaced that controller. You know, so this set of toolings had multiple millions of feet through it. It's got some birthdays. But when you start seeing that shine, this is the time when you come in and do that mirror check and you look in there and you would expect to see that crack of light that follows the roll tooling, and in those shiny areas it's just void, it's gone. The male radius is gone, it's been worn off. They were in the process of putting a new set of tooling on there. They were just trying to get it to go another couple of months, you know how lead times are. It was a little bit rough, but looking for that shiny area is gonna tell you where your radiuses are in trouble. When you buy your machine, it looks like that. And then you get the shiny stuff and it looks like this. It's just an example of kind of where worn tooling goes. It doesn't matter how hard you hit it, there ain't nothing left to form it. You can pinch it and stretch it, it doesn't matter, it's gone. You know, it's about it. A lot of times what ends up happening in this scenario, when your panel starts to get really washed out, as we call it, you start working harder and harder, you're wearing harder on the tooling, you can't get any more out of your overform, you start hitting it earlier in the mill, start to wear that out. When you start to see this washed out panel and you are already down on your overforms, you're down late in the mill, call up your manufacturer and ask them about a recut and fix your overform tooling before you wear out the rest of that roll form. If you're trying to extend some life, fixing a few passes is far and away cheaper than buying a whole new set. You know, that's something where you get your technician out there, somebody like myself can come out and take a look at it, measure things up and see, is this a scenario where I can fix it in a few passes, or do I need a new set, you know? When I'm checking bearings on an Arbor, the quick way that I like to do it is to once again tighten up your acorn nut on the top of the stand adjustment, and then I actually put a couple of blocks in on the Arbor itself, measure the gap, feeler gauge it, put my pry bar in there, give it some pretty good tension, and see if I can get more than 3 or 5 thousandths of difference between when it was gapped and when it was, or when it was prying up and when it wasn't. As long as your adjustment assembly is holding tight and you're actually getting that 3 to 5 thousandths of slop out of the bearing itself, that bearing's done. It's worn. You have too much clearance in it. It's about to start wearing stuff out. It's going to cause some trouble. If you find that slop in it, do I fix it immediately? Do I fix it down the road? Do we need to plan on a rebuild? You know, I pull the stand off. On the operator side, pull that stand off and see how much drops in those arbors. If that roll tooling on a 46-inch roll space drops down 3 inches because that bearing's not holding it up anymore, that bearing's shot. It's done. I want to trade it out right now, because you're going to wear stuff out. You're going to hurt something. If you go to ruin the journals on your arbors and you have to replace arbors because you didn't replace a bearing, that costs you money, costs you time. Back to your spare parts. You need to have arbor bearings on the shelf, and you can trade them out pretty quick. It's not too bad a job. Just swap one of them out, pull the arbor out, trade out the bearings in the stand, put the arbor back in, put your straight edge on there, and align from pass to pass to pass on the edge of that arbor. Make sure you're in alignment, put your roll tooling back on, and take off and run. I do it all the time, probably do it in 30 minutes. If it takes you half a day, that's great. It's still better than you wearing out an arbor, wearing out a bearing block because that bearing was sitting there worn for too long. Back to my favorite of alignment, your lead-in makes or breaks whether you have a good product, whether it's a panel, whether it's anything on the front end of a Rollformer. If that lead-in is not right, you are getting a subpar quality product. Easy thing to do is walk up there, grab a hold of that thing, grab a hold of these rails, give them a shake this way. If it moves more than a click, that little bit, check it out. Figure out where it's ruined at, because there's probably a bushing out. There's probably an adjustment screw that's out. Maybe it's the actual mounting of the lead-in itself. You're gonna see, so if you have taper in your panel, let's say your overlap leg has 3/16 of overlap here and over 1/2 inch on the other end. That panel didn't run straight through your Rollformer. And there's 2 culprits, that's it. The lead-in wasn't square, or it wasn't tight. I don't mean, if you're running it too tight and you're rolling an edge, that's trouble, but a lot of times I see on a short coupled Rollformer from a shear, they will basically use the shear's lead-in guides to align their Rollformer and leave it open. And if you get away with it, that's great. If your conveyor between your shear and your Rollformer has that torn up nasty edge where that little piece flops around and it runs around a million times, it's taking the leading edge of that panel and it's moving it all over the place. Tighten up your leading guides, get it correct without the panel touching the shear, run it through, and do you have a straight square panel? If you do not, then your lead-in is wrong. There's a few different ways that you can go through and line up that lead-in. Make small adjustments. So you get it tight, it's right on the edge of your panel, you run it through, you got a tapered edge, you make half of the adjustment you think you need to. Because if you get in trouble with that lead-in and get it out of square too bad, it's a pain. They're rough to get back in, and I'm sure some of you have been down that road. If you have intermittent taper, a lot of times it comes down to the length of the part. So all my long panels have taper, my short panels don't, or vice versa. That's generally because you have an alignment issue with your shear or with some of your entry equipment, however your machine's set up. And what I like to do is to get my lead-in set up correctly, run a part through, I don't have any taper, I know that lead-in's right. So then I take a 10-foot, 12-foot panel, or blank, run it into the Rollformer and leave 5 foot of it hanging out in front of the lead-in. Then I run through the shear with new material off the coil and overlap those 2 pieces of material laying out on a conveyor. If the edges are in line, you are in line. You're gonna see that when that thing runs out and they're sitting there at a crisscrossed angle, you need to either move your entry equipment or move your Rollformer to where you're not pulling tension through your conveyor from the shear to the roll former. I do that whenever I'm setting up a new equipment. You know, that's the easiest way. I don't know how many string lines people have drawn and dots they put on the floor and all those kinds of things. Until the material doesn't line up, it doesn't matter, you know. This is an extreme example. I actually went to this customer because they were having drive faults. They were faulting out on velocity. They're getting this error on the screen that says drive fault, whatever, excessive velocity, which basically means that it was spinning out and losing control. And they wanted to replace the drive. They said it didn't ever happen before, the drive's bad. Well, my people get online, you know, we actually had a remote connection to this machine, and they said, nah, the drive's acting right, you know, it's got good info, it's right. And I got there and come to find out it was all because their stock reel was in such bad alignment with their lead-in guides that they had worn the material into the lead-in guides. And you can't see it on the back side of the right-hand side, but it's worn just as bad over there. So essentially their coil was shifted off too far, and they were running material through the lead-in guides and wore them out. And the operator, when I get there, I ask him about it, and he says, yeah, I've been having to really tighten it up because my holes aren't in the right location. You know, we ended up replacing lead-in guides. We replaced a bunch of punches, you know, and a bunch of time. My tech trip's not cheap, you know, all because of alignment. You know, it was out of alignment. It was terribly out of alignment, and they let it get it so bad that it worn out their equipment. You know, alignment's king in roll forming. It's the way it is. Some of my favorite things on troubleshooting is blame the material. Right? That's what you guys do. This is the exit side of a Bradbury purlin mill. This is when it's easy to say that part's not straight. Why not? Because of that. You know, that's why it's not straight. So one of the first things I'm doing if I'm checking for panel distortion or your Caesar Z's or whatever it is, your purlin or panel or whatever it is, if you have a fixture involved, take it out. I want your profile to be dimensionally correct first. Whether the aesthetics are right doesn't necessarily matter, because if your panel doesn't have the correct angles and the correct widths and things like that, I don't care if it doesn't lap yet. Yeah, we're gonna get there. But if it's not dimensionally correct when it's coming out of your roll former, there's a different problem. You can't fix dimensions with a fixture. You're not gonna fix that with your straightener. You know, you need to be dimensionally correct through your roll former with your progression. You know, all of those things point back to alignment. They're gonna point back to something being worn out. You know, we're gonna find that your panel's double tracking through pass 5. Why is that? Because it's out of alignment. The bearing's gone in pass 4. You know, those are the kind of things you have to find. I wanna eliminate any of the aesthetics to help troubleshoot. I want it dimensionally correct, and then we aesthetically fix the panel or whatever the profile is, your J trim or whatever it is, you know. So honestly, check the material. Do you have camber in it? In trim coil, that slit edge, it's the drop off of something else. There are so many times that slitter's not set up right, and you get a wavy edge on one side, which is honestly that wavy edge is longer than the other side. I mean, if you went through and measured it very accurately, it's longer, it's stretched. And if you run that wavy edge on your little narrow panel or little narrow blank going through your J trim, yeah, that J's gonna twist. It's gonna look terrible. It's gonna come out of the sweep, and we're gonna try to fix it with this fixture. But it was all because you had a wavy edge on the material coming in. You know, did you change your yield strength? Did you get different coil from somebody else? It's a different thing. It's not the same yield strength. It doesn't have the same elongation. Your tensile strength's different, and you're still running it through that same machine with the same settings, and it doesn't look very good. Well, check your material. You know, is it really what it's made for? You know, there's a lot of times I know on ours, some of our trim mills, But that's for, 60 KSI material. And the guy wants to take his drop off of his 80 and run it through there. And everybody does, but it's not necessarily set up that way. Checking your strip widths. If you have worn out roll tooling, and let's say you're on a trapezoidal standing seam line, and you have worn roll tooling, your strip width that you bought the machine with probably won't work at the end of its life. It's gonna be too wide. You're not using enough material to where your runouts are accurate. If you're hitting on, on a tooling stop on the operator side, and if you move it to the drive side a little bit and it still crashes, maybe you have worn tooling, or maybe your strip width's just too wide. That happens, or too narrow. Check your strip widths, make sure they're right. Like I say, dodge your fixtures, get them out of the way. Those are for aesthetics. That's makeup. Make sure your gap's correct. I'm a big fan of jogging very slowly. I think if I can find the problem in whatever the profile is, I'll jog that thing through just at a snail's pace and get it pass to pass. Check behind that pass you just touched, jog it to the next one, check in front of it. If I'm getting a pop mark in, the middle half of this ag panel, you can see where it gathers tension, it gathers that bubble, it stretches out. You got a speed mismatch because you got a worn out spur gear. Those kind of things, you can find them at a slow speed. If you say, I made an adjustment on pass 5, you push the go button and it rips another one out there, problem's still there. It's hard to diagnose at high speed. I know that you see different pop marks, you see different oil canning at a high speed versus a low speed, but you can generally find those tension issues, the bubbling issues at a slow speed. It'll still be there. Back again to taper, checking your lap. It's all alignment. Alignment is king. It really, really is. If you have trouble and something used to work, I would be willing to bet that there is an alignment issue that has showed up because something is worn out or something's changed or somebody made a bad adjustment on a roll tooling, or the Leadin got smacked by a forklift, or your coil or your uncoiler got hit by the forklift or whatever. There's so many times that things were designed to be in alignment and you don't have to look at that. You don't worry about it. The machine's built that way and it works. But then all of a sudden that thing gets out of alignment that it was set up with originally. And it's a head scratcher. Why did this change? It's probably alignment. Twist and trim parts. So like your J, you're running that uneven corner and that thing wants to come out like a screwball. Well, most likely that is because somewhere it's too tight. It's being pinched. Almost exclusively you are pinching that somewhere because you are elongating one of those radiuses. Maybe not your hem, maybe the first radius in, who knows? If you elongate any one of those radiuses, it is longer than the one on the opposite side, and it's got to go somewhere, and that turns into twist. It's because it has to stretch it. That mirror check, looking for that pinch point, going through with your feeler gauges, going through with the pin gauge. You don't need to know how the roll tooling was designed or any of those kinds of things to tell you that I'm running, 19 thousandths material and I have 4 thousandths worth of gap on this radius. That's a problem. That is a problem. Go through and check that kind of stuff out. And like I say, eliminate fixtures to get your natural part, put the fixture on it to fix the aesthetics. So make sure you have a good dimensional part before you start trying to fix it. Most important things. Alignment is king. Stick to your lubrication schedule. If you don't have one, make one. Take care of that Rollformer. It's going to take care of you. Put cheap material in this end, get expensive material out of this end, you might as well change its oil once in a while. Looking for variances in your product. Just because that your product is a high enough quality to get it out the door doesn't mean it's as good as when you started. And figure out why. If it's washed out because you have worn out roll tooling, yeah, that's nature of the beast. If you notice that, your ridge cap just it has different flair than it used to. That doesn't lap as well. The customer's starting to complain a little bit. You know, it's still good, but why? What's the difference? What changed? If you diagnose that while it's still acceptable and you haven't worn anything out, you haven't trashed anything yet, you know, you can probably dodge a bigger bullet. Look for those variances, even if your product's acceptable. You know, good enough is, you know, just good enough, really. And like I say, simplify the issues. I'm super big on that. You can find the root problem. You can always find the root problem. It might take a little bit to get there, but don't fix symptoms. Don't put a Band-Aid on a Band-Aid. You know, let's figure out where the problem is and simplify your problems. You know, I talk 100 miles an hour and I know it. I'm a wrench turner. I go out and I work on equipment. I'm not a speaker. So if there's anything that I dodged or I went over too fast or there's something you guys want to talk about, that's great. You can talk about it now, you can hit me up with the show, we can meet afterwards, that's all fine. I got asked to do this here a couple of weeks ago and I was like, yeah, sure, I'll do that. I like to talk. I like machines, you know. I'm not a speaker. So I'm here to work on Rollformers, you know. Like I say, my name is John Rogers. I work for the Bradbury Co. If there's anything you guys have questions about, just give me a call. I appreciate your time.
One thing that can also help is make sure your tooling, even if just one tooling is loose or partially worn out, back in.
It changes your progression.
It does.
Absolutely.
Yeah. So, you know, it doesn't matter just to go in and jiggle the tooling, every one by one.
Oh, so if your arbor nuts aren't tight and you actually have slop in the roll tooling on the arbor. Yeah, that'll give that same chatter wear out a keyway. Absolutely.
One of the things that we do is, you know, you talked about tolerance, getting out of place over time. We take a template panel, whether it be a profile or a trim piece, and we of course get our machine, or we get the machine back to tolerance. We actually write template panel on there, put it on the wall, and at the start of each day, we're putting that panel on top, or we're aligning it with the first piece that comes out to make sure we're not slowly losing that. We kind of are able to catch things before it gets too far out of whack.
I love that. We see that a lot when they set up a new machine and they get it going. There'll always be somebody that comes out and says, "Save that one.
Yeah.
Nobody touch it. Don't look at it. Put that somewhere."
But maybe you get a couple of them because the original one tends to disappear sometimes.
Yeah. Well, I appreciate you guys' time. If there's anything you want to